Today we are going to solve multi-step equations, and when we are solving multi-step equations we are going to follow the rule of GEMDAS in a backward order because we need to undo whatever that was done to the variable. Here's your vocabulary. Pause for a second and copy these down. In order to solve single-step equations, we are going to think about what was happened to the variable, and we are going to undo every step that was happened. In this case, variable was subtracted by 6, so we're going to undo everything, and whenever we're undoing everything, we're going to follow the order of operations backwards. Because if you were to simplify an expression, you would use order of operations, so we are trying to undo everything that was done to the variable. We will use reverse order of operations. X was subtracted by 6, so we're going to start by adding 6 on both sides, and negative 2 plus 6 is going to be positive 4. On the other side we have X left. Now adding 6 on both sides, if you guys remember, that would be addition property of equality, and 4 is equal to x is same as writing x is equal to 4. This would be symmetric property of equality. Now how do we know the answer we have found is correct? We're going to substitute that in the original equation. Our original equation was x is equal to x minus 6. We're going to substitute that 4 instead of x. So you will have negative 2. Would it be equal? Is it equal to 4 minus negative 6? And in order to solve it, in order to check, we must see an equal statement at the end, a true statement at the end. Negative 2 is yes equal to negative 2. That confirms that our answer was correct. Here's a second example. In this example, we need to leave the variable alone by getting rid of the fraction 3/4. One way to get rid of a fraction is to multiply it by its reciprocal. So reciprocal of 3/4 is 4 over 3. So if we multiply each side of the equation by 4 over 3, then these will simplify, these will also simplify, and we will have 1 times x is equal to negative 12 times 4 over 3. Now 1 times x is x. Negative 12 times 4 over 3, you can simplify first then multiply. That would be the easiest case. You can simplify 12 by 3, that would be 4 times. You can simplify 3 by 3, that would be 1 time. And our answer would be negative 4 times 4 divided by 1. Then x is equal to negative 16. Is this answer correct? Let's check. Here's my check step. In order to do the check step, I will substitute the answer in the original equation. Original equation was 3 over 4 times x is equal to negative 12. So I need to go ahead and substitute negative 16 in here. 3 over 4 times negative 16 is equal to, or is it equal, that's what we're checking, and negative 12. 3 over 4 times negative 16, we can divide before multiplying. Negative 16 divided by 4, 4 times, and negative 4 times. 4 divided by 4 is 1 time, so I have 3 times negative 4 divided by 1 is equal to negative 12. Negative 12, that's what we were checking, is yes equal to negative 12, which confirms that our answer was correct. Here's your U-try. Make sure to do your check step to confirm that answer is correct. Now we are going to look into two-step equations. To solve two-step equations, we are going to gather all the variables on one side of the equal sign. In this case, it will be easier to gather all of them on the left side. To do that, we are going to undo the positive 7x by adding negative 7x on both sides of the equation. We would have 10x minus 7x on one side and 7x minus 7x plus 12 on the other side. 7x minus 7x is going to be 0x. 10x minus 7x is going to be 3x. We have 3x is equal to 12. We will undo multiplication of 3 by dividing each side of the equation by 3. These will cancel. X is equal to 4. Now let's see if our answer was correct. We will substitute our answer into the original equation. Our original equation is 10x is equal to 7x plus 12. Now on the original equation, after we substitute, we will use order of operations and see if both sides of the equation is going to be equal. 7 times 4 plus 12 is here. 4 times 10 is 40. Is it equal to 28 plus 12? 40 is yes, equal to 40. If we were to find a different answer than 40 is equal to 40, for example, 40 is equal to 25, which would be a not true statement, that indicates our answer was not correct. Then you would go back to your steps and then recheck your steps to confirm that you find a new answer, and you will substitute your new answer in the original equation. Check to see if your result is going to be a true statement. Here's another example with two-step equations. In this case, we're going to undo everything that was done to the variable with reverse order operation order. X was added by 3 and then the sum was multiplied by 1/3. So we're going to undo the 1/3 first and then take care of the 3. Multiplication of 1/3, we can undo it by multiplying each side with its reciprocal, 3 over 1. Multiply each side by its reciprocal, 3 over 1. These are cancelled, simplified. 3 divided by 3 is 1. 1 times this x plus 3 expression is still x plus 3 is equal to 15. Now it's reduced down to a one-step equation. I can add -3 on both sides, and that will bring us x is equal to 12 as the final answer. Is my answer true? I cannot know without doing a check step. Write your original equation, 1/3 x plus 3 is equal to 5, and substitute your result into the original equation. 1/3 times 12 plus 3, is it equal to 5? Now, whenever we are applying our check step, we are not going to do the same solution steps we have done. We just need to evaluate both sides and then see whether it's equal or not. Whenever we are evaluating, we're going to follow the order of operations. So, grouping first. 1/3 times 15, is it equal to 5? 1/3 times 15 is equal to 5. Yes, equal to 5. That shows our answer was correct. Here's your U-try. Here is U-try 3. Here's U-try 4. Now let's look into single-step literal equations. Literal equations are equations that only have or mostly have variables. So we would isolate one of the variables, the one that's being asked, and try to get rid of all the other variables by using inverse order of operations. In order to find m, we're going to see what's next to m. In this problem, m has been multiplied by a c squared. In order to leave m alone, you need to undo this multiplication by dividing each side by c squared. So these c squared can be simplified. Both top and bottom can be divided by c squared. That's 1. On the right side, you have m. On the left side, you have e divided by c squared. To make it look nicer, you can write m is equal to e over c squared, which symmetric property would allow us to go from this step to next step. That would be symmetric property. There's another m here. There is a check step on these, but we're not going to cover them yet. Here's another example of single-step literal equations. M plus n is equal to g. To find n, we're going to undo everything that's next to the n. N was added by an m. So we're going to undo that addition. In order to undo the addition, we're going to subtract or add a negative m to each side. Add a negative m to each side. So these are going to add to 0. N is equal to g minus m. And that would be the final answer. Here is your U-try. We will also have multi-step literal equations, and to find the result on these, again, we are going to try to isolate the variable that's been asked. In this case, we need to isolate g. Whenever we are isolating g, we're going to use reverse order of operations. First thing we want to undo is the subtraction in here by adding x on each side. So we would have 2m plus x is equal to 4g. Now, 4g is 4 times g. In order to undo the multiplication, we're going to have to divide each side by 4. When I divide the other side, I need to divide the entire side by 4. These are simplified to be 1. G is equal to 2m plus x over 4. We can rewrite as g is equal to 2m plus x divided by 4, the simplest form. Or looks nicer this way. Here's your U-try. Last thing we're going to look into is interval notation. Take a moment to write down your notes. In the example here, we have values that are greater than -3. Values that are greater than -3 are going to be located on the right side of -3. Because of the arrow to the right side, we're going to consider all the values that are greater than -3 until positive infinity. Let's write this as an inequality first. Let's say it's an x value, and our x value is greater than -3. When we are considering all the x values that are greater than -3, if we want to write that with interval notation, we will just write the set of all solutions. In this case, solutions should be starting from -3 and continuing up to positive infinity. Whenever we are writing this set notation, we would write our term numbers in least to greatest order. -3 is less than positive infinity. On the second one, our inequality would be x is less than or equal to 2. That means we're going to take all the x values that are less than or equal to 2, and those x values will start from 2, go down all the way to negative infinity. Our lowest value on the number set on the solution set is going to be negative infinity, and the solutions are going to go up all the way to 2, and 2 is going to be included in the solutions. Therefore, we're going to use a square bracket instead of a parenthesis. A parenthesis means the number is not included, and brackets means the number is included in the solution set. When a number is not included in the solution set, we use open circle and parenthesis. When a number is included, we use filled circle and square brackets to indicate. Here's your U-try. Now we are going to look backwards and write the inequality from interval notation. On the first example, we have square bracket indicating that our number is included. The critical number in this case is -4, and that number is included, and our x values are starting from -4 and going up. So all the x values are greater than or equal to -4. If we were to graph that, here is -4 is the critical number that we are looking for, and it's going to go up. X values are greater than -4. On the second example, we have x values starting from -infinity till 2, but 2 is not included. So we will have the x values starting from -infinity, meaning x values -infinity till 2. That will make all the x values less than 2. So here is x is less than 2. If we were to graph that, we would put 2 here, and all the x values are less than that. That's it for today. Please bring any of your questions to the class.